Hello, smart fellow. Welcome to our physics discussion, that is physics in a smart way. In my last video, we have started with the uses of calculus in science. In science, we have talked about derivatives, and as you might have gone through, if not, I'd like you to go through this again so that this video will become more clearer to you. So, as we had discussed in our last video, that is physics for mathematics number 5, we had gone through the issue, or we had discussed the topic that so far as a curve is concerned, the slope at a particular position of the curve can be given by dy by dx, or derivative of y with respect to x. I won't elaborate that because we have gone through in a detailed way. Some of you might be wondering why we are so much interested in finding the slope. In fact, the word slope here is a bit of misnomer that hides many things with that. When we say slope at a particular point on a curve is given as dy by dx, y and x, they can represent many different physical quantities. In this video, we'll be elaborating that how derivative can be used, applied, to find out some special quantities which are not usually possible in your regular mathematics that you have gone at the school level. You have heard of speed and terms like velocity and all that. I am confining to speed. Okay. Speed, so far as the formula is concerned at your school level, I am talking of the formula at your school level. Speed is usually referred to as s by t. S is the distance and t is the time. Now at the 11th level, we may make a small bit of modification, that is delta s by delta t. Here s and delta s, they mean the same thing. But thing is that when you are measuring s, the speed of a body, then you are forced to keep the body at s equal to 0 or your 0 mark. In delta s, body may start from any point. You take the note of the reading of the first point, you take the reading of the last point or the point at the end of your time interval. The difference between them, those readings, will be giving you delta s. Similarly, when you take t, when the motion of the body starts, the body for which you are interested for velocity, you have to make your stopwatch on. But when you say delta t, we know that stopwatch may be running sometime before. But when the event occurs or the body starts to move, in our case, we take the note of time, that is t1. And when the time interval ends, we make the note of time, that is t2. So now you know delta t, or the time interval of our event or time interval of our motion, will be t2 minus t1. So thereby writing s by t was your school level way, but writing in delta s by delta t gives us more freedom. Otherwise, there is no such great difference. But there is a term known as instantaneous speed. You can use that also for instantaneous velocity, but because velocity involves some vectors, I don't want to complicate it. Our basic need is to get our feelings clear, get our ideas clear on the issue. So thereby, we don't make it complicated. Instantaneous speed, that means speed of the object at a particular at a particular at a particular position or instant of time. We use in both the ways. Suppose a body starts to move at 10 o'clock, that continues to move till 11 o'clock. I may be interested, maybe a question comes in, what was the speed of the body at 10:20? 10:20. So that is an example of instantaneous speed. Or maybe a body is going from a position A to position B on a road. There is an intermediate point somehow in between A and B, that is C. So the question can be, when the body is just crossing C, what was the speed? So then you use instantaneous speed. There the meaning is speed at a particular position. So it is used in both the ways and both are popular. So that is written as instantaneous speed. If you mark it as V or something like that, sorry, instantaneous speed, if you mark it as V or like that, then we write that V is usually, it is written with a little bit of help of mathematics. Again, the limit comes in. Limit delta t tends to 0, delta s by delta t, that becomes same as ds by dt. That is the presentation of instantaneous speed in science. Okay, we borrow some ideas of mathematics. We know that is limit delta t tends to 0, delta s by delta t. That is same as ds by dt. At the moment you see the term ds by dt, you clearly recognize that that is the derivative of s with respect to time. That is the derivative of distance with respect to time. Okay, that may be written like that, but exactly you have to comprehend, we have to understand what that really means. There are many different type of speeds, average speed or mean speed, instantaneous speed. Okay, we can create other terms also, but average and instantaneous, they are very popular. So we got a vehicle moving on a road, and there is a point P on the vehicle, maybe a light post, maybe a significant object where when you pass by, we got no difficulty to mark it. Okay. Our body moves. So our question was, the issue was, what is its velocity exactly as it passes point P? Sometimes we use several terms in science, in mathematics, and if you think about it more deeply, then those terms, they seem to be meaningless. Here, we encounter a thing like this, that is instantaneous speed. Speed at a particular point. Think about that. You may pause the video and think about that. Speed at a particular point has got no way to be determined. Nobody can determine it. Maybe God, we do not know, attributes of him or her. But at a particular point, speed cannot be found out because you cannot find any s or t. You cannot find delta s or delta t at a particular point because you know point has got no length, no breadth. How can you find delta s and how can you find delta t and divide it? And to cross a particular point, that takes no time. So If we temporarily remove from our mind and think about a practical solution, then if you are given or somebody asks you, you find the speed at a particular point, the more practical choice you can make is that you consider 2 points in the close neighborhood of that point, one at the front, other at the back. Okay, you measure the distance between the 2 points, that is delta S, and at the same time, you also measure with the help of a stopwatch what was the time taken to cover that delta S. Then delta S by delta T, if you make it, you can find something and you can present to the your question setter. But now take a case, he is not satisfied. His argument or horse can be that, okay, I told you to find out the speed at a particular point when the vehicle is crossing P. The vehicle is assumed also point as a point also. Instead of, and when you measure this delta S and delta T, instead of finding the speed at a particular point, you have given me the average speed of all the points in the neighborhood of P1 and P2 or in between P1 and P2. And that we have to admit. Then the person again puts a cross question that I didn't ask you to find out. My question was to find out the speed when the vehicle crosses a point P. But you know, we have made, using our mind, using our thinking, we have made a decision, we have gone for some measurements. If the person is too stubborn, then using that idea, we try to pacify him or her. We'll be trying to take P1 and P2 close to each other. So when they are close to each other, then you say, then you report to him that you see, we have made the so-called separation or made the gap very small. Now every point is very close to the point P. We got a smaller delta S, we got a smaller delta T. Will you be satisfied? He or she says no. Still then, you have given me, if you make delta S by delta T, new delta S and new delta T, you have given me the average of all the points in between these two marks. So then you become slightly hopeless, but still we know we are human beings. Our job is to strive for the case. We should hope against hope. You make these points still closer and find a third delta S by delta T. Still he is not satisfied. You go on doing this, you gradually make delta S smaller and smaller. As a consequence, delta T becomes smaller and smaller, but still the person is not satisfied. In the last of our measurement, we know delta S will be such a small one that almost is at the end of our measurement. Delta T also becomes a very small one. And under those conditions, delta S is approaching zero. Delta T also will be very small, that approaches zero. So when delta S approaches zero, you know at that time, delta S is branded as ds and delta T is branded as dt. A very small distance, very small distance, infinitely small distance in the neighborhood of point P, and consequently very small time to cover it. And that delta S by delta T, which in fact is ds by dt, will be giving us the speed that is maximum you can do. You cannot go any further. If the person is not satisfied, you raise your hands, you surrender, you simply say, no, I can't do anything more. Okay, now you understand the meaning of ds by dt. Usually, The speed is referred as, you might have gone through this at your school level. The speed is rate of change of distance. We express in a different way. Rate of change of distance with respect to time. Rate of change of distance with respect to time. With respect to time. Okay, if you express this delta S by delta T in words, in English, then that will be rate of change of distance with respect to time. How distance is changing with time, and we say rate of change, so we have to divide the time. So how the distance is changing with respect to time, that is also another way to define speed or to put down the speed. Okay, and we have found that using the calculus method or using derivative as ds by dt. In fact, your derivative is not only used or is not only useful in finding the instantaneous speed or instantaneous velocities, that can give us, that can help us in finding out the rate of change of many things with respect to many other things if this quantity is dependent on this quantity. Okay, maybe the rate of change of the price of petrol or diesel with respect to time, that is a day, that is half a day, something like that. The rate of change of the flow of electric charge through a wire with respect to time, that we express as electric current. Instantaneous current is expressed as dq by dt. It's expressed as dq, sorry, my pen got stuck up. So instantaneous current is expressed as dq by dt. But usually at your school level, you used to express current as q by t. The same thing happens here. The same logic can be applied here. The instantaneous current is expressed as a rate of flow of charge with respect to time. So there are many quantities which can be expressed as a derivative, and they give us the instantaneous value of a particular physical quantity at a particular instant of time or at a particular position. Okay, thank you. Again, if you like, you can give a like, you can subscribe, you can share among your friends. Okay, so that will be all for today. Next class or the next video, you will be going to the use of integration, how integration can be practically applied in our physical sciences.